And for those of you who are less familiar with the Applied Climate Program, it is either a 2-semester program if you come from as an undergraduate into our program, or 3 semesters if you're coming from outside the university. And the program really focuses on getting students to the point where they can apply climate data, climate analytics to real world decision-making problems. And so often we collaborate with various stakeholders. You're going to get a set of projects. You'll see some overlaps. You'll see some differences. And our first project, Brian, is his final presentation in the program. And Brian, you're going to be moving to South Dakota shortly to take a position with the Weather Services. And I think Brian's project has been super interesting, and I've learned a lot about this from Brian. But also, one of the mentors of this project is a former graduate of this program. So people never actually quite leave this program. We keep them entrained, and I hope Brian stays involved as well. And he is going to talk to us a little bit about the emissions modeling that he's been doing for the state of Michigan. And he'll probably tell you a little bit about the My Climate program and plan that he has been involved with.
Thank you, everyone, for coming. Heather, where should I stand? Here?
You can stand. Yeah.
Okay, yeah. I don't just want to be in frame for the video there. But yeah, thank you everyone for coming. This is a very good turnout. I'm impressed. Basically my presentation, like Jeremy mentioned, was creating an emissions model in accordance with the My Healthy Climate Plan in partnership with Michigan's Department of Energy, Great Lakes and the Environment. For those of you who came to my presentation last semester, I kind of had like that 4-step plan. Yeah, that went out the window. Different scope, and we kind of refined it and focused in on creating a Michigan-specific emissions model. So real quick, I'm going to go over what the My Healthy Climate Plan is, how EGLE responded to, maybe responded is the wrong word, but EGLE's kind of plan and their path to achieving these. We'll go into some of the specifics, and then I'll give a demo of the model that I created. All right, so first things first, My Healthy Climate Plan, just to catch everyone up to speed on this. Governor Gretchen Whitmer of Michigan in 2020 created the My Healthy Climate Plan, essentially charging EGLE to carry out and make sure that the goals in the plan were achieved. Some goals: carbon neutrality by 2050. That's the big one. And there are some sub goals here: 60% carbon by 2030. Also want to close coal power plants by 2030, 2 million electric vehicles, and preserve 30% of Michigan's land and water by 2030. There's a lot more, but these are just kind of the big highlights. Obviously, if I tried to go into all of it, we would be here for an hour. So EGLE put together this Priority Climate Action Plan recently. They released it in March as part of the Climate Pollution Reduction Grant, which is a federal grant given to the state in order to help combat climate change. And they released kind of a 4 pillars type of approach. The first one, clean the electric grid. Then they want to electrify vehicles and increase public transit, repair and decarbonize homes and businesses, and then drive clean innovation in industry. So these are kind of the 4 categories in their plan. They split that up into 10 different reduction measures, which I then took in and inputted into the model. Real quick, I want to get into where the data comes from. There are a few tools online that allow you to play with emissions sources, including the RMI Energy Policy Simulator and the AVERT Avoided Emissions and Generation tool. Yes, that is not a typo. I don't know why they did it that way. But those were kind of the 2 main tools that EGLE used to assimilate data, in addition to some manual calculations. This data is not necessarily the easiest thing to quantify, so they had to get a little creative in spots to kind of bring together everything that they wanted, because those first 2 tools are not all encompassing. They don't have everything that EGLE wanted. So here's what the RMI Energy Policy Simulator looks like. The Avert tool is just kind of a chart mostly, so not as interesting. But this is also kind of how I base the output of my model to look like. You can see in the green here are Michigan's climate goals. As you can see, assuming nothing new happens, then we're kind of in trouble. But with a little bit of a policy change, you can see that CO2 equivalent emissions decreasing. So reduction measure 1, there's going to be 10 of these. I'm going to go through them relatively quickly, but these all are going to look pretty much the same. Here's like the name, some implementation milestones, and this is what that graph would look like if this reduction measure is completely met. So reduction measure 1, drive clean energy deployment and renewable energy, especially citing it on former industrial sites and brownfields. So essentially turning formerly polluting sites into green energy sites. This is kind of the most, I don't want to say most impactful, but you can see the biggest decrease on the chart with reduction measure 1. 50% by 2030 is one of the bigger goals, and 100% by 2050 as well. An interim goal, 60% by 2035. I believe we're sitting at about 16% presently. So we got some work to do to hit those milestones. Reduction measure 2, this one is the closing the coal power plants early retirement that I mentioned earlier. They want to achieve that by 2030. Also pretty big impact, relatively speaking, on the individual scale. So drive electrification and fuel switching in existing buildings. This is kind of a incentive for current buildings to switch over, electrifying households that currently rely on fuel. You'll see this acronym a lot here, LIDAC, which is low income and disadvantaged community. So Michigan has a number of those, and that's a place that EGLE really wants to emphasize, bringing change and accessible green energy to in the future. Oops, skipped one. Reduction measure 4, reduce household fossil energy use. Pretty similar, 70% by 2030. And then reduction measure 5, these kind of 3 all go together under that clean, like current households and businesses. This one is the government and nonprofit facilities. It's a relatively small portion of the population of emissions, which is why you see very little impact, but still good thing to take into mind, and assumes 20% increase in building energy efficiency by 2030 and 40% by 2050. Reduction measure 6, electrify the state and public fleets, especially across low-income communities. It's really important, this one, for low-income communities because they're way more likely to commute to work. So if we can get that to electricity or electric vehicles, essentially, that's going to have a pretty big impact, more than you would initially think. They want to do full electrification of light-duty vehicles by 2033 and everything by 2040. And then it's pretty similar, improving infrastructure for public transit and increasing routes, frequency, and reliability of options. Again, very important for low-income communities. And essentially their goal is starting in 2025, increase that by 15% per year, and then 0.12% per year after that, which is essentially just a natural growth factor. So by 2030, they essentially want to have this goal accomplished. Reduction measure 8, encourage adoption of electric vehicles. This is kind of your private, something that we would all own, electric vehicles. Those kind of what you think of there. 50% reduction per year through 2030 again, which translates to 2 million electric vehicles on the road by 2030. We are currently at about 50,000 in the state of Michigan. So buy those electric vehicles, everybody, if you want to support reduction measure 8. Reduction measure 9, we're almost there. Encourage industrial innovation to advance energy efficiency and switch over to cleaner manufacturing technologies, again, with the emphasis on low-income communities. And they want the 11% reduction by 2050 through the greenhouse gas reporting system, essentially a way that companies self-report their emissions. And reduction measure 10, this deals with food waste and wastewater treatment, specifically focusing on methane, reducing food waste 50% by 2030 and 36% reduction in wastewater treatment by 2050. This one is kind of based on the data that I've worked with EGLE on, is the big contributor that you really need to cut down on. So now I want to get into a quick demo of the model that I've put together. And you'll notice that on the slideshow that I had, each reduction measure was taken on its own. But my tool, first and foremost, combines all of them together. So Sloan, pick your favorite reduction measure.
Number 5.
Number 5.
Popular favorite.
All you do, set it to true. Let's get another one, Kira.
8.
8. Easy as that, run a couple cells, and you have your new output. You guys chose some of the least impactful measures. Let's get another couple in here, Jen.
Let's do number 2.
Number 2, good choice.
We turn them all on and see how close we get.
Yeah, I will show that in a minute. Anyone else have a favorite reduction measure? Erica.
Number 1.
Number 1, okay. And there you go. Here is your guys' climate output. By 2050, you'll still be emitting 100 million metric tons of CO2, but we're on the right track. So you're probably thinking, wow, Brian, that's pretty cool, but we can do better. And you're so right. So we talked a lot about the different goals that they had in mind. So from here, I've split that into the different goals. So let's say we accomplish something by 2030, but you're not sure if you can get it by 2050. There's a model for that now. And so if we have all those set to true, here's what our graph looks like. You can see that this is achievable if we manage to hit all these goals. That's where it looks like with everything on, Jeremy. I believe the actual value down there is like 0.2 million metric tons, so still a little bit. But again, these models it's very much an estimate, so if we can get close, that's pretty good. Now you're probably also wondering, Brian, what if I want to do my own thing? And I'm pleased to tell you that there is also capacity for that. This is kind of the big goal of the project, is to create a custom reduction measure input. So you can input any percent, any reduction measure, any year, and we'll get an output on that. So let's go down to that real quick. All right. Can I get a reduction measure 1 to 10? Tim.
Number 1.
Number 1. What percentage, Tim?
Let's do half of it.
Half of it. And when?
2040.
2040, okay. A little bit behind EGLE's schedule, but I won't ding you for that. And so now here we also have a population input, because not all policies are statewide. So if you have something that's just in the city of Detroit, for example, you can deal with that. So Tim, would you like to work with the entire population?
No way, that's too many people.
Okay, too many people. How many people is your policy going to impact?
About 4 million.
4 million, okay. And I'm not going to download, but that is an option for anyone else using it. I've downloaded enough text files from this program. And so Tim, here is a table of your reduction measure. And here's the impact that you have created. All right, let's try another one.
Tim, I'm sorry to say you have very little impact.
That's because I didn't work with the entire state of Michigan.
Yeah.
All right, someone else. Anyone else want to give it a go? Claire.
Okay, let's do reduction measure 5.
5. Let's go for one with a little more impact.
Okay, how about 4?
Percent?
72.
Very precise.
And what year?
Let's do 2036.
2036. And let's work with the
Yes,
entire
let's work with the-
population.
Yes.
And here is your impact, Claire.
Okay.
Now, let's add something on to this graph. We don't want to just deal with one reduction measure. Let's put another one on top of it. So, anyone else? Kira,
Yeah, the wastewater one. I can't remember which number what that one was.
I believe it was 10, yeah. Percentage?
Let's go for 100% reduction
100%,
by 2050.
2050. Entire
Yeah,
population?
everybody.
So now you can see this impact has been added on to what Claire had on. And you can see that further increase now. Here's where the 2036 line is. You can kind of see that change in slope a little bit. You go down a little bit slower. So essentially this tool allows you to put in as many or as little custom reduction measure inputs as you like, as well as it has the pre-existing measures toggleable as well. I have them all off for the purposes of this model or this demonstration essentially. But if you come down here, you can see stored both of your reduction measures. We could keep going if we want, but I think this kind of gets the point across. Let me go back to my slideshow. So obviously this model is very much a first draft. It's not perfect. First off, everything is based on a lot of assumptions. We're projecting into the future, like 25 years out. That's not a great thing to base a ton of certainty in. We also assume that the reduction of all the reduction measures are fully met. That's not necessarily going to happen. I hate to be a pessimistic, take a pessimistic viewpoint there, but it may or may not happen. And we do have to put together an effort to make sure that these are achieved. It also, for custom percentages, linear interpolation is used because obviously if you want to enter any percent, that would be a lot of work to match every single one. And again, that's not necessarily a realistic take, but for the sake of the model, that is the, I guess, simplest approach that we can take to produce an output. So it also cannot currently handle multiple custom inputs. So if you put in two reduction measure 4s, it's going to override and take the last one. So there's no current comparison one. That's something I briefly attempted, but just didn't have a lot of time to finish. But I would love to get that implemented into this model. Currently cannot handle the split reduction one that I showed earlier. That's also something that I just didn't have time for. Working with EGLE was a bit of a slow process at times, so getting the data was later than I would have liked, but we still managed to put something together. And no spatial data capacity at the moment. But again, that would be more towards a population. So if you knew your population within your spatial data, that's not a huge problem. I just wanted to say a special thanks to Sarah Hutchinson from EGLE and the Accenture team, Graham and the people at MSU, as well as Heather, Jeremy, and my fellow MEng climate students. Thank you so much, everyone.